All right, so picking up with number 12, we're back to using our box method for the word problem. And number 12 and actually I think 13 are two special types of box problem, word problems, in the sense that we're dealing with tickets. All right, so we call this a ticket problem. And with a ticket problem, you are going to gray out or X out or black out this bottom middle box here, because we are not going to be using this box during a ticket problem. And again, if you stop by the PASS lab and you pick up one of these reference sheets here, you will see, let me move that over just a little bit, center it. You will see that for investment and ticket problems, this bottom box is blacked out. So again, I tried to make this reference sheet really easy to follow. And so we're not going to be using this bottom box, bottom middle, because it's a ticket problem. And you might be asking yourself, well, how do I know it's a ticket problem? Well, that's a good question. It normally says the word ticket in the first sentence. And let's see if that's true here. Ron and Kathy are ticket sellers at their class play. Ron is handling student tickets that sell for $2 each, and Kathy is selling adult tickets for $6.50 each. If their total income for 22 tickets was $107, how many did Ron sell? All right, well, if you watched the first word problem a couple videos back where we use the box method, you'll recall that we always put X in this top left box, and we always put Y in the box right below it. And then the bottom left box here is going to be the total number of tickets that were sold. And if we go back to our word problem, we can see that 22 tickets were sold. All right. Well, again, we know that there are two types of tickets being sold here. One that is more expensive, one that is less expensive. And I usually assign X to be the less expensive product being sold. And the word problem tells us that those tickets are $2 and that the more expensive tickets, the adult tickets, are $6.50. All right, and now this bottom right box for ticket problems is going to be the total amount of ticket sales. All right, and if we go to the word problem here, we can see that all of the tickets brought in a total of $107. All right, and now that we have our boxes filled out, with exception to these two, let's go ahead and multiply left to right. So we have X times 2, well, that's just 2X. And we have Y times $6.50, well, that's just 6.5Y. And we can leave this last 0 off because it's a decimal. And so 6.50 and 6.5 are the same thing. They're equivalent. All right, and now that we have all of our grid filled out, just like before, this left column becomes one equation, this right column becomes another equation, and we're just going to put a plus in between the first two boxes, and then equals, and then equals. And so let's pull this information out. So we have X plus Y equals 22, and 2X plus 6.5y equals 107. All right, and here again, we've got ourselves a system of equations, don't we, that we can solve either by elimination or substitution. You're going to get the same answer either way. So whichever method you're more comfortable with, go ahead and solve that way. All right, I think we'll go ahead and solve this one by elimination. And let's see, we have a positive 2x here in our second equation. So let's go ahead and get the first equation to have a negative 2x so that we can get these x's to cancel. And right now we have a positive x. So if I want to go from a positive x to a negative 2x, I'll multiply by negative 2. And of course, I can't just randomly multiply one term of an equation. I have to multiply the whole equation by the same number so that this new equation is equivalent, right? If I just randomly multiplied one part of an equation, well, then it's not going to be balanced. We're going to end up with the wrong answer. So let's go ahead and now write the result of this multiplication right below. So negative 2 times x gives us negative 2x. Negative 2 times y gives us negative 2y. And then negative 2 times positive 22 is going to give us a negative 44. And let's go ahead now and add these two equations together. 2x minus 2x goes away. And 6.5y minus 2y gives us 4.5y. And 107 minus 44 is going to give us a 63. And solving for y, we'll divide by 4.5, divide by 4.5, and that leaves us with y equals 14. All right, so now that we've solved for y, let's go ahead and take this value and plug it into, how about this first equation? Because it's a relatively simple equation, and we can solve for x, right? So if we take this value, plug it in for y, we'll be able to solve for x. So that's x plus y equals 22. So again, we're going to plug in right there. X plus 14 equals 22. Solving for x, we'll subtract 14 from both sides, and so x equals 8. All right, again, be careful. Don't just randomly put your solutions into an ordered pair and move on. This may not be what they're asking you. While this is correct, this is the solution to this system that we created, this may not be the question they're asking us. So always go back to your word problem and read that last line again, because the last line is the question that they're asking us to solve for. So if their total income for 22 tickets was $107, how many did Ron sell? So they just want us to tell them how many Ron sold. Well, let's see. Ron was responsible for handling student tickets that sell for $2. So Ron is our X, right? $2 corresponded to the number of tickets, or X. So if we go here, we see that X equals 8, which means there were 8 tickets sold. And since Ron was responsible for selling those tickets, we can say that Ron sold 8 tickets. All right, and there we have it. This is the actual answer that your professor is going to be looking for. All right, let's go ahead and take a look at question number 13 in our next video. See you there.